This is the first video in a series of videos on the topic of time value of money. Time value of money is going to give us the mathematical underpinnings of the financial decisions we'll learn how to make later. It's called time value of money because it has to do with how the value of money changes over time. So for example, $1 today is not worth the same as $1 in the future, $1 a year ago. Mainly because of what we'd call opportunity cost, which is you could take that dollar today, you could invest it in something, earn an interest rate, and you'd have more money in the future. So it takes slightly more money a year from today to equal the same amount of money today. Alright, as we go through this lecture, we're going to do problems based on all these different topics I've listed up here. But this first lecture, we're just going to start with a simple concept, which is on the difference between simple interest versus compound interest. Most investments grow at what's called a compound interest rate. What's it mean to be simple versus compound? Simple interest, you earn interest only on your initial investment. So we'll do a little example here. Let's say we start with value at year 0. V0 means value today. Time 0 is today. Let's say we start with $1,000 or whatever currency you want it to be. You can make it euros or whatever. And let's say the interest rate, the going interest rate on a one-year investment is 10%. So if I were to invest this $1,000, how much would I have in 1 year? You'd earn 10% of your 1,000, that's $100. So add your $100 in, you're going to have $1,100. You've made 10% of 1,000. Simple interest, you always earn $100 because you always earn 10% of your initial investment. So when we get to year 2, it's $1,200. We get to year 3, it's $1,300, and so forth. It keeps growing $100 each year. It grows linearly, where it's sloping up $100 each year. So it's got a constant slope where it's growing $100 each year. That's simple interest. Most investments actually earn compound interest, which is you don't just earn interest on your initial 1,000, you earn interest on the interest that you got paid previously. So let's do the compound interest case. Again, we'll start with $1,000 or 1,000 euros or 1,000 pounds or whatever you want to use. Year 1's not going to be any different. You're going to earn $100 because you're going to earn 10% of 1,000, so you're going to be at $1,100. But then, starting the next year, we're going to actually have more money in the compound than the simple case. And that's because we're not going to earn 10% of 1,000, we're going to earn 10% of 1,100. We'll earn 10% of 1,000, but we'll also earn 10% of the $100 we got in the previous year. Basically, we're going to take that $100 we received and we're going to reinvest it. So at year 0, we had $1,000 invested, we made 10% of that, which is 100. But that's from year 0 to 1. From year 1 to 2, we're actually going to reinvest that $100 and we're going to earn interest on the whole $1,100, not just on the 1,000. Year 2 is actually going to come out to $1,210. It's $10 higher in the compound case than in the simple case. Why is that? Well, you made your $100 on your 1,000, but you also made 10% of the $100 interest you had the prior year. 10% of 100 is $10. That's why you end up with $10 more in the compound interest case. I'm going to write out a mathematical formula to show you exactly how to do this in a second. But for now, let's just list them up here. In year 3, you're going to earn 10% on the whole 1,210. It's like you now take your 1,210 and reinvest the whole thing and earn 10%. 10% higher than 1,210 is 1,331. So now we're actually $31 higher than in the simple interest case. You could keep doing this forever and it's going to get to be a bigger and bigger difference over time. In the short run, the difference between compound interest and simple interest isn't that big a deal. But when you expand it out to many years, it becomes a really big deal. Let me show you a chart here. This is showing the same numbers we just worked with. Blue line represents what the value of your investment would be if you're earning simple interest 10% starting with 1,000. Red line is your investment if you're earning compound interest 10% starting at 1,000. It goes up to 30 years here, but you can see, say the blue line, for example, starts at 1,000. After 30 years, you're up to about $4,000. So you've grown from 1,000 to 4,000 over 30 years. The red line, which represents compound interest, you've grown from 1,000 up to about $16,000. Obviously a very big difference there between $16,000 and $4,000. It's a $12,000 difference. So in all our math problems, we're going to assume things grow at a compound interest rate, not at a simple interest rate, which makes math a little bit harder because everything grows at this exponential curve. It'd actually be easier if everything grew at a straight line. It would make the math easier. Okay, but we're going to have to work with everything as it's growing exponentially. So you earn interest on interest. It compounds. The interest compounds as you earn more interest based on that interest, hence the name compound interest, and it ends up growing exponentially like this. Now let's go back to the dry erase board and let's look at the actual math that we use to get those compound interest, the value of our investment each year. It looks like this. So if you start with the value of your investment at year 0, that's your initial investment. Let's say you want to know how much your investment's going to be worth at year t, so t years out. You multiply it by 1 plus the interest rate to the tth power. Why is that? Well, if you want to increase something just 1 year at an interest rate, so let's say you started with 1,000 and you multiplied it by 1.1, that's the same as multiplying it by 1 plus 10%. That'll get you the next year's, that'll get you 10% higher, which will get you $1,100. Then if you want to go to the next year, you could take $1,100 and again multiply it by 1.1. That'll get you 1210, which is what we said. This was V0, this was V1, this was V2. You could do it again. Take your 1210, multiply it by 1.1, and you'd get 1331. So each time when you want to go 1 year in the future, you multiply it by 1 plus the interest rate. Don't do it as a percent. So don't do 1 plus 10, that's 11. Do it as 1 plus 0.1. So that's 1.1. Each time you multiply it by 1.1, you'll get the next year's value. So if you do that, let's say you want to go 30 years out, you're going to end up multiplying by 1.1 30 times in a row, which is the same as taking 1 plus the interest rate to the 30th power. So that's why this formula works. Most of our time value money stuff, the basic time value money problems, are just basically working with this formula right here. So sometimes we're going to be saying, all right, if I invest so much for so many years at so much interest rate, how much will I have in the future? Or we might flip it around and say, if I want to have this much in the future, how much do I have to invest today? Or we might say, all right, I have this much, I want to have this much, what interest rate do I have to earn? Or we could also solve for t and say, how long do I have to invest to get a certain return? But given any of those three, you can solve for the fourth one. And those are kind of the basic time value money problems, which we'll do on the next video. The nice thing about this class is we don't ever actually have to work with this formula because we have a thing called a financial calculator, which is going to do all the work for us. This is a look at Texas Instruments BA2 Plus, which is the most popular business finance calculator around these parts. But as I mentioned in a previous lecture, if you don't have one of these, just a regular graphing calculator, any kind of fancy calculator will have financial functions in it somewhere, or Excel will do it for you, or if you have a smartphone, there's free smartphone apps you can download to do all this. But this is a look at the basic finance calculator. It's these buttons up here that are kind of unique to the finance calculator. First off, this row of gray buttons, N, I/Y, PV, FV, PMT. Actually goes PV, PMT, FV. Those are used to do this basic finance formula, which I wrote on the board. Let me go back to that. All right, back here on the dry erase board, I've rewritten the compound interest formula to use the variables in your calculator. So FV stands for future value. Before I wrote V sub t, so it's value at year t. Future value, and down here I have it out as a graphical diagram. So it's actually easier to see. Let's use this one. If this is times 0, so this is today, and then each period you have a go across until you get up to n periods. So for starters, n, that's the leftmost gray button on your calculator. That stands for the number of periods. Most of the time that'll be number of years that we're going to invest. But we'll do problems where we have number of months, number of days. But most of the time it's number of years. So n is the number of years you want to go out between your what's called your PV is your present value and your future value. Present value is the value of your investment today at time 0. Future value is the value of your investment at time n. I/Y I usually write down here at the bottom, that's the interest rate. Stands for interest per year, assuming that you're in yearly periods. And then PMT stands for payment. We haven't really talked about annuities yet, and in this formula up here there is no PMT, so it's usually just 0 on a basic time value money problem. But you could have a problem where you have to either receive or pay a constant amount each period. It's a very standard type problem. That's called an annuity. And so when that happens, we'll plug a payment in here. But if you plug any of the 4 numbers in, you can always solve for the 5th one. So if you want to solve for a present value, you'll know number of periods, the future value, the interest rate, and if there's any payment, it'll go in here. You plug those 4 into your calculator, and it'll solve for the 5th one. So we're going to do a whole bunch of problems in the next video. For now, I'm going to leave this video just looking at this. We'll come right back, and we'll actually apply this to some real problems.